building blocks of code. When building a game in Unity, you often need to store information, such as a player's age or the current time. Variables are perfect for storing data. Int stores integers, whole numbers, without decimals, such as 123 or -123. Double stores floating point numbers with decimals, such as 19.99 or -19.99. Char stores single characters, such as A or B. Char values are surrounded by single quotes. String stores text, such as Hello World. String values are surrounded by double quotes. Bool stores values with two states, true or false. The variable score is set to 10 in the C# script. If this script runs, the output will be 10 showing in the console because at this moment in time, score is holding the variable 10. In Unity C#, data types play a key role in defining the kind of data that can be stored in variables. C# provides a variety of primitive data types as well as complex data types, while Unity adds its own types specifically tailored for game development, like Vector3, GameObject, and Transform. Primitive data types. The most common data types in Unity are string, integer, float, Boolean, array. These are basic C# data types that are built into the language. String stores a sequence of characters. Example, string player, name, Chakr, John. Int, integer, stores whole numbers. Example, int score is equal to 10. Float, floating point number, stores decimal numbers. In Unity, it's often used for values like speed, time, etc. You need to append f to the number. Example, float speed is equal to 5.0f. Double precision floating point number, stores larger and more precise decimal numbers, not commonly used in Unity because float is more efficient. Example, double large number is equal to 10,000.113456. Bool, Boolean, stores a true or false value. Example, bool is jumping equals to false. Char, character, stores a single character. Example, char grade is equal to A. Unity-specific data types. Unity adds several custom types that are essential for working with objects and components in the game engine. Vector2 represents a 2D vector with X and Y components. Example, vector2 position equals to new vector2, 10.of, 20.0f. Vector3a stores whole numbers. Example, vector3 velocity equals to new vector3, 0, 0, 0. Transform represents an object's position, rotation, and scale in 3D space. Every game object has a transform component. Example, transform player, transform equals to transform. Game object represents any object in a Unity scene. Example, game object enemy equals to game object. Find enemy. Rigid body. A rigid body component is used to make an object act under the laws of physics. It enables physics interactions such as movement, rotation, gravity, and collisions. Example, rigid body RB equals to get component. Complex data types. These are data types that can hold more complex data, such as collections of data or user-defined types. Array stores a fixed-size sequence of elements of the same data type. Example, int scores equals to new int. List, generic list. A flexible collection of elements that can dynamically resize. It's part of system.collections.generic. Example, list score list equals to new list. Dictionary, a collection that stores key value pairs. Useful when you need to map one type of data to another. Example, dictionary player scores equals to new dictionary. Commenting in Unity C# follows the same principles as standard C#. Commenting. Commenting in code is a best practice that helps make your code more readable and maintainable. It provides context and explanations for what the code is doing, which is especially useful when working in teams or revisiting your own code after some time. Benefits of commenting. Clarity. Comments explain the purpose of code sections, making it easier to understand. Maintenance. Helps in maintaining and updating code by providing insights into the logic. Collaboration. Facilitates better collaboration among team members by making the codebase more accessible. Debugging. Comments can help identify the purpose of code blocks, aiding in debugging and troubleshooting. Single-line comments. Use // to add a comment on a single line. Typically used for brief explanations, notes, or to temporarily disable code. Multi-line comments. Use /* and */ for comments that span multiple lines. Useful for longer explanations or for temporarily disabling larger sections of code. XML documentation comments. Use / to generate XML documentation for your methods and classes. These comments provide automatic tooltips when you hover over the method or variable in Visual Studio or similar IDEs. Especially useful for documenting public methods and classes in larger projects. Operators are used to perform operations on variables and values. We use the plus operator to add together two values, for example, int x equals to 100 plus 50. Although the plus operator is often used to add together two values, like in the example above, it can also be used to add together a variable and a value, or a variable and another variable, for example. Int sum2 equals to sum1 plus 250. In this case, sum1 is a variable, and 250 is a value. Arithmetic operators. Arithmetic operators are used to perform common mathematical operations. Assignment operators. Assignment operators are used to assign values to variables. Comparison operators. Comparison operators are used to compare two values, or variables. This is important in programming because it helps us to find answers and make decisions. Logical operators. As with comparison operators, you can also test for true or false values with logical operators. Logical operators are used to determine the logic between variables or values. Let's reflect on what we have learned so far.